Hello, hi, namaste. This is Surabhi, your master teacher of chemistry at Vedantu. Hello, good evening. Hi, Priyanka. Hey, Vignesh. Hi, Srilata. Hey, Priyanka. Hi, Sudarshan. Hey, Suchi. Good evening, people. How are you? All good? Hello, hello, hello. Hi, Sudhakar. हाँ जी पक्का फ्राइडे को एनटीएससी. Good evening. Hi, Mukt. Hey, Srilata's birthday. Happy birthday, Srilata. Happy birthday. Thank you, Ayushi. Good evening, everyone. So, ready to start new chapter, periodic classification of elements, and आपका last chapter. हाँ जी आज मेंटी है. Yes. Happy. Hi. Today's your birthday too. Pakka. Hi, Pallavi. Good evening. Hey, Shahid. Ready? Okay then. Hello. Okay. So in today's session, we'll learn why we have a periodic table. That is something which we have to know, right? Because we know it's not that easy. There are 118 elements, and for 10th standard, maybe you have to learn around 30 to 40 elements. So why do we have a periodic table? What do you think? According to you, why is there a need to classify elements? Let's see. Let's hear it from you guys. Thank you, Sukanda. Hey, Abhishek. To make it easy. What should be easy? To make what easy? Because it is very hard. Acha. To arrange them according to their properties. What is the use of remembering? Hi, Tanmay. It's very easy to understand if they are organized. Okay, that's a very good answer. That's a very good answer. Achha, let us see. Okay, and there is the link in the description box if you want to join us on the long-term courses and attend all the live sessions of all the master teachers along with some bonuses where all of your problems can be resolved. So just visit the link given in the description box and choose your grade, board, click on the get subscription. Do not forget to use the coupon code SURPRO for additional 20% discount from our site. Okay, and we have a Telegram group now, so if you are interested you can join. And I guess you already have started preparing to be on the hot seat, right? So just download the Vedantu app and play week quiz every day. So shuru kare? Hello Shahid. Okay, so the thing is, we have 118 elements, right? We know 118 elements. So we have this groups, periods, we already have studied the reactivity series. Now it is very easy for us to remember. Achha, group 1, the number of valence electron is 1. So it is electropositive in nature. It tends to lose electron. Group 17. So we can aram se only by looking at its position. The position of the element in the periodic table, it is very easy for us to say, right? So I'll know which is the electronegative. So as chlorine is in the 17th group, it is electronegative. Its atomic size is small. So only by looking at its position in the periodic table, I am able to tell about its properties. है ना? हाँ. But all these elements have different properties, right? And out of these 118 elements, only 98 are naturally occurring. But the thing is, before now, though we have nice modern periodic table, so long ago, the scientists found it difficult to organize all that was known about the elements. Because, they had to study each and every element. Acha, they had to take one. Acha, they had to do this chemical reactions and all that because it was not organized. right? So it was very difficult for them to study or to organize whatever they knew about the elements. So that is the reason they wanted acha. So if they find some similarities in the properties of elements, they can group them together, right? So that's how the attempt to make a periodic table was started. So they wanted to make it easy, so they wanted to organize the elements in such a way that so only by looking at one group you can talk about or study all the properties of all the elements which falls into that group. Okay. So why classification is needed? Imagine, so we have wardrobe full of clothes, right? So what I do is, so you are late, you have to go somewhere, and the moment you open wardrobe, you have no idea where the top which you want to wear is, because it's completely disorganized. The denims and tops, kurtis, everything are together. But if you have classified it properly, but the denims go here, and the tops and the kurtis and the traditional clothes, everything. So if it is classified properly, then the moment you open the wardrobe, you will know where exactly it is, right? So finding it is very easy. Or even supermarkets we prefer open market or supermarket. So in between them, so I would prefer supermarket because it is well organized. I will know the moment I enter the supermarket, I will know, acha, if I have to get the cake or ice cream, I have to go this way. I don't have to look around, right? So this, for the exact same reason, we wanted to have a classification among elements too. Yes, we have Mentee today. So that is the reason classification was very much needed, to organize the periodic table, to organize the elements into groups, so that it will be easy for us to study them. See, metals, non-metals, metalloids, only 3. Metals, maybe we have different types depending on the valence electron, their chemical property is different. So if it is smaller size, its property is different from the element or an atom with larger size, right? So it is very, very important for us to classify the elements according to their properties. So where the elements with similar properties, they will fall into the same group. Okay? Yes, of course. So that's when, as I told you, scientists started attempting to come up with the classification of elements, so according to their properties. So such attempts, the early attempt, it was done by Johann Wolfgang Dobereiner. So he was a German scientist. So from 1817 to 1829. Okay, so he started working on coming up with a periodic table. What he did was, so he took 3 elements. Okay, he identified some groups having 3 elements each, only 3 elements. That is the reason it is called as triads. Tri means 3, right? So a group of 3 elements, he arranged them. But randomly you cannot put 3 elements, right? There should be some similarities. There should be some similarities with respect to their properties. What was that? And so what was the thing is, so there will be 3 elements. Let's consider element M1, M2, M3. So if you take the average of atomic masses of M1 and M3, so you will get the atomic mass of M2. So if you arrange these 3 elements in the triad according to their increasing atomic mass, the arrangement is very important. So if you arrange them according to the increasing atomic mass, so if you take the average of the M1 and M3 atomic mass, you will end up getting the atomic mass of M2. So this was what he said. See, I am arranging the elements in such a way that, so the first and third element ka average atomic mass will give me the atomic mass of second element, and it was followed by very few elements. Okay, Hansi, very good, Keshwi. So when the 3 elements in a triad, see, arrangement, the order is very important, order of increasing atomic mass. So the second element, so its atomic mass was roughly the average of the other 2 elements, first and second. Ha. Yes, very good. So example, so what happened, no, there are actually, we say only 3, so there are 5 actually, 5 triads, but the rest of the elements, they didn't follow these triads. He could only, collect or classify the elements into triads only for 3 sets, 3 to 5 sets, okay. So take the triad consisting of lithium, sodium and potassium. So lithium, sodium, potassium, so we have arranged them according to the increasing order of their atomic mass. So their respective atomic mass, lithium is 6.9 and potassium is 39.0. So if you take the average, how much will you get? Can you tell me? Yes? Can you tell me 6.9, 39 ka average? How much will we get? 23. Oh, pakka 23. No point, nothing. 17.91. 22.7. 6.9 plus 39.0. How can you get 23? Exact 23? Huh? But yeah. So the respective atomic mass, see, lithium ka atomic mass is 6.9 and potassium is 39.0. If you take the average, so roughly, not the exact value, but roughly it will be around 23, right? You guys did it. So this is what he was talking about. So what is the average of the atomic masses of lithium and potassium? Do it and tell me. Do not just say 23, ma'am. 23 plus somewhat. Okay. See, so 6.9, 31, 39.1, if you take the average, it will come around 23 something. And then element, calcium, barium ka atomic mass le lo, so it will be roughly, not exact value, so it will be roughly around 87.6. So if you, what is the Dobereiner's triad? So if you take the average of the atomic masses of the first and third element, you will get the atomic mass of the second element. But what is the thing? So when you are arranging the elements, it has to be according to the increasing order of their atomic masses. Yes. So not only that, sulfur, selenium and tellurium. So that is also another triad. Sulfur, selenium and tellurium. Okay, but are these the only elements we know? No, right? So what is the drawback is Dobereiner could identify only 3 to 5 triads. So in the span from 1817 to 1829, he could identify, or he could, just group only 3 to 5 such triads from the elements. But what about the rest? So that is the major drawback of Dobereiner's triad. But this guy was the first one to attempt the classification of elements. Ayo. Okay. Then what was the next one? So this, so we cannot use it, but it would have been so easy for you guys, no? Only 5 sets. Okay. Failed. So in the year 1866, John Newland. So how many of you, you have learned the classical music? Hello. How many of you? See, because only, but that's a major drawback, right? What about the rest of the elements? He couldn't even classify them. So you all know that, there is the sa re ga ma pa da ni, hai na? Sa re ga ma pa da ni. New to class, hello. Yes. So what he did was, so he arranged, okay, so he also took all the elements, whatever the elements they were known then, which were discovered. So what he did was, he arranged them according to the increasing order of their atomic masses. What he observed was, so the first and eighth element, their properties were similar. he could see the repetition of properties. First element का जो भी properties था, they were repeated in the 8th element. हाँ. Yes. So he started with the element having the lowest atomic mass, that is hydrogen, we all know. So he arranged whatever the elements he knew then, so according to the increasing order of atomic mass. So what was his observation? That every eighth element has properties similar to that of first. So in the case of musical notes, we have sa re ga ma pa da ni, right? And the next note is again sa, है ना? So this is the first one, this is the 7th note. So the 8th note is the repetition of the first one. So the same thing, the similar observation was also made when he arranged the elements according to the increasing atomic masses. So first and 8th element ka properties were similar. So that is exactly the reason he gave us the law of octaves, octa 8, right? Haan. Hey Syed, how are you? Oh my god, it's been so long. So if the chemical elements are arranged according to increasing atomic weight, those with similar physical and chemical properties, they occur after each interval of 7 elements. So 1, 2, 3, 4, 5, 6, 7, and the 8th element will have similar physical and chemical properties. This is what is the law of octaves. If the chemical elements, so you just go on arranging the elements according to what? Increasing atomic mass. So the elements with similar physical and chemical properties, they will repeat after every interval of 7 elements. Okay, you can see here. So 1, 2, 3, 4, 5, 6, 7, and this is 8. So that means hydrogen and fluorine have similar properties. Lithium and sodium have similar properties. Okay? Okay. So the properties of lithium and sodium were found similar. See here you can see beryllium and magnesium, boron and aluminium, they were found similar. But what is the drawback? He did a good job, right? He arranged all the elements according to the increasing atomic mass, and he even observed the similarity in the properties. So there was some periodicity, that is the properties, they repeated itself at regular interval. That was also done. But the drawback was this holds good only for the lighter elements, that is only till calcium it was applicable. After that, so the properties were not repeated. So the first drawback is only this law of octaves was applicable only up to calcium, that is only for the light elements. Their atomic masses is less, right, compared to the 20, 20, 25, 26 elements, 26th element ka, the atomic masses is very high. So this law holds good only for the lighter elements, that too only up to calcium. That is the first drawback. And the other one is, if you look at his table, law of octaves, so what he did was, he just adjusted. He wanted to fit all the elements. He wanted to fit. He was like, I am going to do it. I will fit all the known elements into my table. So when he was doing that, so even the elements with different properties, they were put together. Arey, how is it possible? See what happens. I'll just show it to you. Where is it? Just give me a minute. Okay. See, iron, cobalt, nickel, they are all metals, right? They have similar properties. But he put cobalt and nickel together and iron with some non-metals. But how is it possible? So in order to just fit all the known elements into his periodic table, he just put the elements with different properties into the same group. So that is another major limitation or drawback of Newlands law of octaves. See, unlike elements also they were put into the same group. Okay. Yes. So cobalt and nickel are in the same slot. Okay, that is I agree. Fine. Cobalt and nickel, they have similar properties. But what about the iron? They have to be together, right? But cobalt and nickel, they were put in the group of non-metals, fluorine, chlorine, bromine. The chemical properties were completely different. That is the major limitation. And after the discovery of noble gases, so comparatively noble gases were discovered later, right? So they didn't fit in the arrangement suggested by Newland. He couldn't fit the noble gases into his periodic table, so that is the another limitation. Very good. He messed it up. Hey Manchi. Okay. But with the lighter elements, that two first 20 elements till calcium, up to calcium, his periodic table worked well. So there were repetition in the properties, so everything, it fitted well, but only for the lighter elements. So that is the achievement. Okay. But now, see, from triads, that is 3 elements to 8 elements, it is kind of the improvement. Hai na? So gradually they are realizing. You got it, right? You got the difference. First, only triads, set of 3 elements. Now, so he observed that the periodicity in the properties. So when you arrange the elements in the increasing order, so the properties are repeating at the regular interval. So that was shown by the Newlands law of octaves. Okay. Yes, it will be put in the modern periodic table, of course. That's right. Okay. Next is Mendeleev's periodic table. So this is the closest periodic table to which we are using now. So comparatively, he did an amazing job. So what he did, first, so whatever the elements were known, he prepared cards. He was like, Acha, let me write down the element name and the properties, the atomic mass, everything. Okay, so that's the first thing he did. He just wrote down the element name, their chemical and physical properties. Then he went on arranging the elements according to their atomic masses. He also did the same thing. He arranged the elements according to the increasing atomic mass. But there was similarity in the chemical properties also. So what is the similarity? What chemical properties were similar in the elements? We'll see now. He too failed. So when Mendeleev started his work, 63 elements were known. 63. Now we have 118. But when he started working on the periodic table, 63 elements were known. So as I told you, what he did was, so he first made the cards. Let me just, and then he went on arranging the elements according to the increasing order of atomic mass. Then he observed, so is there any similarity between two elements? Chemical properties along with the physical properties. Then he put them in the same group. So what are the chemical properties? If the oxides and hydrides formed by them are similar. Okay, that is, you can have different types of oxides, right? RO is possible, RO2, R2O, RH, RH2. See, the oxide formed by carbon is CO2. Hai na? But with other elements it is different. Na is Na2O. The formation of how the element will react with oxygen and hydrogen. What kind of oxides and hydrides were formed. So if the elements combined with oxygen and hydrogen in the similar manner, if they gave the similar type of oxides and hydrides, he put them into the same group. You want me to repeat again, Anji? See, so for example, if you take group 1, let's take group 1. Can you tell me what are the elements present? Li2O, Na2O, K2O. These are the oxides formed. Do you agree? Li2O, Na2O, K2O. Hai na? We are not considering hydrogen. H2O. Huh. But if you go to group 2, the formation, the oxides they form is different. CaO, MgO it is. This is R2O. The general formula of the oxide formed by these elements is R2O. But these elements it is RO. So whichever the elements which form similar type of oxides and hydrides, he put them into the same group. Got it? Ha. Why to? Okay. So this was treated as the basic property. So if I and Ayushi, we form same kind of oxides, so we were put into the same group. That's the basic. Okay? Ha, got it? Very good. So he observed that most of the elements got a place in periodic table and were arranged in the order of their increasing atomic mass. So the chemical properties were also similar, but even they were arranged according to the increasing atomic mass also. Here also he observed that the properties, the chemical properties are repeating at the regular interval. So based on his observations, he gave us the law that the properties of elements are the periodic function of their atomic masses. What is the meaning of this periodic function? Something which repeats itself at regular intervals. See, group 1 mein sodium, potassium, they are forming same kind of oxides. Group 2 mein, that is its chemical property is repeating at the regular interval. Sodium, potassium, lithium, sodium. So that based on his observations, how the properties they kept repeating at the regular interval, he formulated the law, that is Mendeleev's periodic law, which states that the properties of elements are the periodic function of their atomic masses. So his periodic table contains groups and periods. So periods are the horizontal rows and groups are vertical columns. You can see here. See, this was done based on the chemical properties, and even so elements are in the increasing order of their atomic mass. So the horizontal rows are called periods and the vertical columns, they are called as groups. Okay. But of course there were drawbacks in his periodic table also. So if you can see here, cobalt and nickel, so they are not in the increasing order. So this order is wrong, right? Because what is the atomic mass of cobalt and nickel? 58.9, 58.7. So nickel has to come before cobalt, right? But in his periodic table, cobalt is first, uske baad nickel hai. So wrong order of the atomic masses of elements. Okay. But there we are considering the atomic number, right? Hitler. Oh, Hitler is here. But the very good thing he did was, I really liked Mendeleev's periodic table, because you know, he was like, I am right, I know what I'm doing. He knew what he was doing. So he didn't just randomly arrange, okay? He was not like, I'll just go on arranging the elements and I won't see. So if he thought, so something is missing here. So few elements. So is group mein, so something is missing. Some other element has to be here. So he left the gaps and he just didn't leave it. So he tried to predict their properties. So by looking at the chemical properties of the other elements, he tried to predict the property of the element which has not even been discovered yet. So that motivated the other scientists to discover the elements. So that is a huge achievement of Mendeleev's periodic table. He left gaps and then he predicted the properties of the unknown, the elements which has not been discovered yet, and guess what? So his predictions were right, almost right. So the atomic mass densities were almost similar. So whatever he discovered and whatever he predicted, the properties and the discovered element ka properties, the values were so close. So that is another major achievement of Mendeleev's periodic table. Okay. So he called them, he even named them as Eka boron, Eka aluminium, Eka silicon. That is, Eka means first. Okay. So that means boron, and then so there will be a gap. So after boron, this element has to come. So what is the properties of these elements? So after the discovery, as I told you, the properties the values were almost same. Scandium was Eka boron, gallium, Eka aluminium, and germanium is Eka silicon. Okay. So what are the achievements? As I told you, Mendeleev, he left some gaps in the periodic table and then he predicted the properties of those elements which were not discovered yet. And the noble gases, right? So they were mentioned. In the Newlands law of octaves, those noble gases, they didn't fit. But in his periodic table, he didn't alter, okay, without disturbing his periodic table. So he placed the noble gases in a separate group, and it actually was right. So he didn't disturb the periodic table. That's it. So he just placed them in a different group. So that is also another achievement of the Mendeleev's periodic table. So we are very happy with it, right? So whatever he did was right. Chemical properties, physical properties were taken care of, and the elements were arranged according to the increasing order of atomic mass. Okay, noble gases they found a place. Then what is the limitation of Mendeleev's periodic table? So chlorine, okay, it has isotopes, right? 35, 37. But as he has arranged the elements according to the atomic mass, so there should be 2 positions for chlorine. So he couldn't explain isotopes, one limitation. And the position of hydrogen could not be explained. That, to be frank, it is still a doubt. Okay, we are still working on it. Where about the position of hydrogen? Okay, because it behaves as alkali metal also. So should we place them in the first group, or sometimes it behaves as a halogen also? Should we place it in 17th group? So that confusion is still there. But when you go according to the atomic number, 1. Okay. So 2 limitations. So another disadvantage or the limitation was the wrong order of the elements. See, nickel, cobalt, atomic mass, it was not followed. Okay. Is this live school? Ma'am, in class 10, the questions related to this topic will come. Hanji, of course it will come. Hello, Kishore. Hanji, yes, we'll start the Mentee. So, what is your homework is, what was the criteria used by Mendeleev in creating his periodic table? So, please let me know in the comment section what is the answer. So, shall we start? Shall we start the Mentee? Ready, guys? I know. Next class kab hai? Not all, but 30 is must here. You're not supposed to be here. Why? Okay then. We all are excited. Let me just start. I'll just give you the code. Give me a minute. Okay, people, everyone go to www.mentee.com and use the code 6734063. 6734063. I can do it 5103. Can you guess who I am? Right? You guys have joined? 6734063 is the code here. 6734063. Next class is on. You have to click onto the bell icon. You will receive all the notifications. Okay then. How many students do we have here? Join. You are late, Hanji, you are. Yes, 6734063. You're not even a student? That's okay, you can learn something new every day. Already clicked? Okay. Oh, ma'am. Hello. So let me just wait for another minute. Hi, Hari. It's hard. What is hard? This chapter is difficult. No, it's not. Oh, Anthony ji. Acha. Okay. So, come on, people who have not joined yet. Fast. Go to www.mentee.com and use the code 6734063. Okay, then I'll be starting it now. Yeah. Just give me a minute. I'll reduce my screen size. Okay. Do you know Kannada, Hanji? Okay, here is your first question. All the very best. Up to which element the law of octaves was found to be applicable? Oxygen, calcium, cobalt, potassium. Now clear, huh? Easy peasy. It always happens with you, no, Anthony? Be pakka. Acha. Oxygen, not oxygen. Think. 3, 2, 1 and time up. Oh, very good. It is calcium. So the law of octaves, Newlands law of octaves was applicable only till up to calcium. Only for the lighter elements with less atomic mass. Okay? Hanji. Right answer. Very good. Let's see. Sangeeta, do you know me? Yes. Priyanka, Gunjan, Sanchit, Sudhakar, Sukhada, love you ma'am. Oh, same here. Sudarshan, Aishwarya, the 9th grader, Amritavarshini, Ullas. Very good. Okay. 16th place, that's good. Question number 2 on your screen. According to Mendeleev's periodic law, the elements were arranged in the periodic table in the order of. Very easy question. Decreasing atomic masses, increasing atomic mass, decreasing atomic number, increasing atomic number. You answered in 1.82 seconds. That's nice. Let's see. 3, 2, 1 and time's up. Atomic number? No. Atomic number is modern periodic table, about which we will study in the next session. Okay? Mendeleev's periodic table mein, so the elements were arranged according to the increasing atomic mass. Okay. So on the leaderboard we have, who is the fastest? Sukhada, Sudarshan, Sanchit, Riya, Aditi, Gunjan, Aishwarya, Satvika, Sanju loves chemistry. Hi, Vignesh. Very good. Did I answer no? You're not Anthony. You said it, so how will I know? In Mendeleev's periodic table, gaps were left for the elements to be discovered later. Which of the elements found its place in the gap? Germanium, chlorine, oxygen, silicon. I didn't answer. I was just giving you hints. I was trying to confuse you guys. Oh, I know, Tanzila. A, B, C. Think. A, B, C or D. 7 seconds. Hi Anmol. 3, 2, 1 and time up. Yes, it is Giovanni. Very good. क्या बात है जी, क्या बात है. I'm not playing. Okay, so before I show you the leaderboard, guys, in today's session we learned about early attempts of classification. In the next session we'll see how did they come up with the modern periodic table. A very interesting session. Do not miss. So if you don't want to miss, you know what to do. If you are new here and not yet subscribed to our channel, do it, and then like and share this video with all your friends also, so even they can learn like what is the history, how did we come up with the periodic table which we are using now. And if you want to take up the long-term courses, just visit the link given in the description box, and the coupon code is SURPRO. So here is the leaderboard. Okay, so we have Riya, Sudarshan, Satvika, Sanju, Danamma, hey, Aishwarya, Vignesh, Padmanabh. I missed 2 names, I cannot see. Whereas the next session, tomorrow we have a session. So we are starting with the NTSC. We'll be solving previous year question papers, and there will be Mentee also. So do not miss at 1 o'clock. Okay? Okay then. Chalo. Thank you so much, people. Take care. And visit the link, join the Telegram group so that you'll be updated with whatever is going on in the channel. Hey Adi. For 9th, it's tomorrow. Bye-bye. Take care people. Okay. So the link is in the description. Do join if you want all of your problems to be solved, and the coupon code for additional 20% discount, it is SURPRO. And if you have any doubts, please let me know in the comment section, and homework question ka answer to zarur dena. You can reach out to me at surabhi.r@vedantu.com. Thank you so much. NTSC tomorrow at 1 o'clock. Bye-bye, Tanvai. Thank you, Sneha. Okay, bye-bye. Take care. Tata.